So what we would like to do is redo our first example that we did here completely by hand, just now using rejection regions. So what we're going to do is we're going to redo our complete problem, but this time we're going to use rejection regions, whereas last time we did the p-values. Okay, so just to show you that we start out the exact same way, you're going to start out with your claim, just like you did before, is that your test results, that less than 10% of the test results were wrong. So just like before, you'd start out the same way with your claim, and starting out with what symbol do you need? Either the P, the mu, the sigma, and then what kind of inequality do you want? And then what value you'd start out with on the other side. Well, just like before, because you're dealing with a probability or a percentage, you're going to start out with a P in your claim. And this time, they also said less than, just redoing the same problem. So we're just going to use the strictly less than, just like before. Less than what? 10% is our value. Again, we turn that into a decimal of 0.10, so nothing different so far. The question is, where does this fall? Is our H naught or our H1? And that's going to be pretty straightforward. Just like before, it's because you have a less than, not a less than or equal to, that you will put this as your H1. And again, go ahead and label this as your claim for helpfulness later. And then that means your your null hypothesis will be the complement or opposite, which will be the P is greater than or equal to 0.10. Just like before. So nothing else is different at this point. Continuing along, we're testing a proportion. So we want to do R1 prop Z test, just like before. It's going to ask for the same information, a P naught, an X, an N, and a symbol, either not equal to, less than, or greater than, and then it'll let us calculate. So our P naught, just like before, is going to be the P from the null hypothesis, which was the 0.10. So we can go ahead and fill that in. Also, we need our X and our N, which is going to come from our P hat, our sample. So our P hat, which is normally X over N, comes from our sample, which is going to be the 27 out of 300 subjects that said that it actually ended up being wrong. So the 27 out of 300. The 27 will be your X. Your 300 is your total, your N. And the other thing that we were talking about is that this was a situation where when we pick our symbol, you are always going to go based on H1. And H1 has a less than, which is going to tell our calculator to do a left-tailed test and draw a left-tailed picture. So we can go all the way down to the bottom and select calculate, and let's see what our calculator looks like now once we do all this. So continuing along, our calculator would look like the following. Nothing is different. You didn't enter in anything different. It's just what you're going to use is different. When you actually go to press calculate at the bottom, what you're going to have actually is the same exact output. The only difference is what we're going to use, which is now instead of the P value, we're going to use the Z value, which rounds to a Z value of negative 0.58. And I do want to get used to using this terminology because they will use this in the homework, that this is called a test statistic. And this is what we're going to see whether or not is it in the rejection region. Is it in the rejection region? That's our question. Well, before I can even do that, I have to figure out how to come up with my rejection region by drawing a picture of my rejection region. Well, because we had a less than symbol in our H1, our H1 had a less than symbol. That tells us that we're going to have a left-tailed picture. So it'll look something like this with our left tail filled in. And what we're going to be trying to do is to find the z-value that'll match up with this picture. Well, that means I need the area that's going to go in that tail. When you're making a rejection region, the area that goes in the tail or tails is going to be your alpha. Alpha is the area in tail, or if it's two-tailed, both tails, to create the rejection region. Well, if you go back to the original problem, the alpha was 0.05. So that's going to be the area in this left tail here, is the 0.05. So how do I find the z-value? Well, if you remember from way back when, if you've got an area and you want to go backwards and find a z-value, you're going to do an inverse norm. Remember, that's under the distribution key. You have to have the second key, then distribution, and then it's the third or fourth option, the inverse norm. Remember, with inverse norm, you do need an area to the left, which you do have, is 0.05. So 0.05 is what we use. And then you'll press enter on your calculator, and we already said what this was going to be, just to kind of point this out. It's going to be negative 1.645, depending on how you're told around. What does this mean? It means that that is the value that's going to start off our rejection region. So this shaded area in my picture, this green blob, is our rejection region. Anything that falls in there, we reject. If it doesn't fall in there, we don't reject. Well, what are we trying to determine whether or not we reject or not is that test statistic from the calculator, that z-value. So if I were to put it on the same number line, that's negative 0.58, it falls a little bit before that. So there's my test statistic. Is it in the rejection region? No. It is not in the rejection region. It is outside of that. It's not in that left tail. So let's see what that means. So far, just to kind of summarize, our test statistic is not in the rejection region. So what does it mean if we're not in the rejection region? It means we won't reject. Well, if you're not rejecting, you're not accepting either, but you're failing to reject H naught. So let's restate our H naught and our H1 so we don't get confused about what's going on here and what this means. Remember, our H naught is that P was greater than or equal to 0.10, and H1 is P is less than 0.10, and that was our claim. And according to this, because it is not in the rejection region, we're going to, let's see, fail to reject H naught, which means we'll do the opposite with the H1. We'll fail to accept the H1. Again, just like before, there's only one of these that we care about, and we only care about the one where the claim is, which is the one that we're failing to accept. So really, all we need to do is come up with a fancy sentence that describes what's going on here. So remember, what does fail to mean when we write out our fancy sentence? Fail to means we're not able to do anything. There's not enough evidence. So we're going to say there is insufficient evidence to, what are we doing? Well, the claim is there and we're failing to accept, so there's insufficient evidence to accept the claim. And my math lab is going to force you to write out sentences like this, but there'll be little drop-down boxes where you get to choose insufficient or sufficient, accept or reject, that sort of thing. So you won't actually be typing in a full sentence, but it will be kind of equivalent.